Welcome to the OpenAI API with Python. Learn how to use artificial intelligence models in your code. We will cover setup, safe use, and real-world examples. No experience needed, we start from the basics. Running the cell now. What is the OpenAI API? The OpenAI API lets you access advanced AI directly from your programs. You can use it for chatbots, writing help, audio, and more. It connects your code to powerful machine learning models. Running the cell now. Why should you learn the OpenAI API? AI skills will help you automate boring tasks. Get creative by building apps with language, vision, or audio understanding. Stand out with real-world AI projects in your portfolio. Running the cell now. Let us make the notebook less noisy and easier to read. We do this by hiding warning messages. This line hides Python warnings, so your code looks clean. Import NumPy as NP. We set the random seed to 42 for reproducibility. Running the cell now. Here, we've set a random seed and suppressed warnings to create a clean, reproducible environment for working with the OpenAI API. This setup is crucial as it ensures consistent results, which helps when automating tasks or developing creative AI applications. Notice that while there's no output, these preparation steps are foundational for reliable coding in your AI projects. You will still see real errors if something is wrong. That is helpful for learning and debugging. Now we need the OpenAI package, which lets Python connect to the models. You install a new Python library with pip, which is Python's built-in installer. This line tells Python to get the OpenAI package. It will download and set up code we need. Running the cell now. This step installs the OpenAI package, enabling your code to access powerful AI models for language, vision, or audio tasks. Since it only sets up the required library, there is no visible output, but this installation is essential before making API calls to automate tasks or build creative AI applications. You only need to install a package once per environment. After this, we can import OpenAI in our projects. Now let us bring the OpenAI tools and operating system module into our code. The OS module helps us access environment variables such as your API key. This is a comment explaining that we should always import the package before using it. We import the OpenAI class from the OpenAI package to interact with the API. We import the OS module to access environment variables and system functions. Running the cell now. This code snippet shows how to import the OpenAI package, which is the first essential step before using the API in your projects. Although there's no visible output, this setup lets you access powerful AI tools for tasks like text generation or image understanding, aligning with our goal to build creative and automated applications. Now we can begin talking to OpenAI's models. You need an API key to safely access the OpenAI API. The API key is a long code that proves who you are. We keep it private and never share it. Here, we get your key from the system's saved values. This way, the key is kept secret. Running the cell now. This code snippet securely retrieves your OpenAI API key from environment variables, enabling your program to access OpenAI services without exposing sensitive information. Notice there's no visible output. This step is about setting up authentication behind the scenes, a critical foundation before making any API calls in your AI projects. Never put your API key directly in your code. If you share your code, always keep your key hidden. Now let us make a client. A client object lets your code send requests to OpenAI. Create the OpenAI client instance to interact with the API. Initialize the OpenAI client object using the provided API key. Running the cell now. Here, we create an OpenAI client instance to connect our code with the API using your unique key. Although there's no visible output, this setup is crucial. It enables you to send requests and receive AI-powered responses, forming the backbone for automating tasks and building creative AI apps in this lesson. Think of it as your link to the models you will use. Key concepts: prompts, models, completion. Prompt, the message you send to the AI. Model, the brain that answers you, such as GPT-4o or GPT-4.1. Completion, the RA's written reply to your message. We use a messages list for chat-style AI, or just input for quick answers. Running the cell now. Let us make the simplest possible chat call. We will ask the model to say hi back to us. This is a comment explaining that this is a basic chat completion example saying hello. We call the client's chat completion's create method to generate a response. We specify the model to use, which is GPT-4.1 mini, a small and fast model. We provide the messages list containing what the user says to the model. We close the function call to create the chat completion. We print out the content of the RA's first message choice. Running the cell now. Here, the output is the RA's completion responding to the user's prompt hello in a conversational style, demonstrating how the chat completion API uses a messages list to interact. Notice the model GPT-4.1 mini generates a friendly, relevant reply, showcasing the core flow from prompt through model to completion in chat-based AI. Chat completions are great for making chatbots or Q&A helpers. Now you pick what to ask. We will send your question to the model and show the answer. This is a comment telling you to try changing the prompt. This line asks you to enter a question for the chat model. This line starts creating a chat completion request using the client. Here we specify the model name to use for the chat completion. This line provides the user's message to the model as input. This line prints the content of the model's response message. Running the cell now. This output shows the RA's completion in response to the user's prompt, demonstrating how the model generates a relevant, coherent answer based on the message sent. Notice how the prompt directly influences the RA's reply, highlighting the key concept that the prompt shapes the completion you receive from the model. Try anything you are curious about. If you just need a direct answer instead of a chat, use the responses endpoint. Here, we ask it to summarize what an API key means. Comment explaining that we're testing the responses endpoint with a single answer task. Calling the client's responses.create method to generate a response. Specifying the model name to be used for the response generation. Providing the input prompt asking to summarize what an API key is. Ending the call to create the response object. Printing the generated summary text from the response object. Running the cell now. This output shows the RA's single straightforward completion to the prompt asking for a summary of an API key. Notice how the response is concise and focused, illustrating the code's intent to get a clear, direct answer using the responses.create method with a single text input. This demonstrates how prompts and model parameters shape the completion you receive. Use this for summarizing, rewriting, and direct commands. Here is a quick list of handy model names you can use with OpenAI. Each one is made for a special use. This line asks a question about what models you can choose from. This line starts a list called available_models. This line adds the model named GPT-4o to the list. This line adds the model named GPT-4.1 to the list. This line adds the model named GPT-4.1 mini to the list. This line adds the model named text embedding 3 small for embeddings. This line adds the speech-to-text model Whisper 1 to the list. This line adds the text-to-speech models GPT-4o mini TTS to the list. This line closes the list of available models. This line prints out a message followed by the list of available models. Running the cell now. This output lists several example OpenAI models, showing a variety of model types like chat-focused, e.g., GPT-4o, embedding generators, text embedding 3 to small, and speech-related models, Whisper-1. Notice how the prompt was simply to display available models, emphasizing the lesson's point that you specify which model the AI uses when sending a request. This step helps you understand the role of the model in shaping the RE's completion. To see the full list, you need to check OpenAI's official documentation. Embeddings turn text into a list of numbers. These are like fingerprints for meaning. Describe what the code is doing to get vector embeddings for a specific phrase. Call the OpenAI client to create embeddings using the specified model. Specify the model name we want to use for generating embeddings. Provide the input text that we want to convert to an embedding. Close the function call and complete the embedding request. Print the length of the embedding vector returned to understand its size. Running the cell now. This output shows the length of the vector embedding generated for the prompt. Machine learning is fun. Notice that the embedding has 1536 dimensions, which reflects the model's way of representing your input as a high-dimensional numeric vector. This vector is what the model uses internally to understand and relate text for tasks like search or similarity comparisons. Embeddings help with tasks like search, grouping, or recommendation. OpenAI can listen to audio and turn it into text using the Whisper model. You would put your own audio file in place of sample.wav. This is a comment explaining that we are doing speech-to-text with Whisper. We open the audio file as sample.wav in binary read mode. We start the call to the transcription API method of the client. We specify that the model to use is a Whisper-1. We pass the opened audio file to the transcription method. We print out the transcribed text received from the AI. Running the cell now. The error file not found error indicates the code couldn't locate the sample.wav audio file to transcribe. This highlights the importance of providing a valid audio input as the prompt for Whisper, or the model won't have data to process and return a completion. Always ensure your input files are accessible before sending prompts to the AI model. Speech-to-text is helpful for captions, voice notes, and making media searchable. You can also do the opposite. Make OpenAI read words out loud. This code speaks text and saves the sound to a file. This comment explains that the code converts text into speech using a TTS system. This opens a new file called voice.mp3 in write binary mode to save the audio output. This line calls the TTS service to create speech audio using the client object. This specifies which TTS model to use for generating the speech. This sets the voice style or character for the speech synthesis. This is the text input that will be spoken aloud by the TTS model. This writes the generated audio data into the opened MP3 file. Running the cell now. This code demonstrates how to generate speech from text using a text-to-speech TTS model, specifically a GPT-4o Minio TTS. Notice there is no printed output since the result is an audio file, saved as a voice.mp3. The key takeaway is how the prompt, in this case, the string "Hello World," is converted into a speech completion, highlighting the use of a model to produce non-textual output. Great for assistive software or creative voice projects. Error handling: how to handle mistakes. AI models can fail if prompts or keys are wrong. Always check responses before using them. Use try except to catch and explain errors for users. Running the cell now. Let us show how to protect your code from crashes. Here, we ask for a model which does not exist. This is a comment describing the example purpose. Start a try block to catch potential errors. We attempt to call the Chat Completion API. Specify the model parameter with a deliberately incorrect name. Send a message with user role saying hi. Close the API call parentheses. If an error occurs, catch it as the error. Print a message along with the error details. Running the cell now. This output shows an error message caught by the try except block when an invalid model name was used in the API request. Notice how the code gracefully handles the mistake by printing a clear explanation instead of crashing, emphasizing the importance of validating inputs and handling errors to improve user experience. It is faster to find problems if you show a clear error message. The OpenAI API has limits. If you ask too often, it will make you wait. Comment: note about API rate limits and need to slow down if too many requests are sent. Import the time module to enable pausing execution. Start a loop to try 3 times with index I from 0 to 2. Use a try block to attempt making a request to the API. Call the client.responses.create method to get a response from the model. Specify model name and input text with the current loop index inserted. Print the text content of the first output from the response. If there is an exception during the request, handle it here. Print a message asking to wait and show the error message caught. Pause the program for 2 seconds before continuing to the next iteration. Running the cell now. This output shows successful responses from the API for 3 requests, each returning the expected text with no errors encountered. Notice how the code uses try except to catch errors. If the API rate limit was hit, it would print the error and pause before retrying, ensuring the program doesn't crash. This demonstrates robust error handling in practice when making multiple API calls. This keeps your code respectful and avoids blocking. You should always check if the AI makes sense. Sometimes it can be wrong or confused. We add a comment to remind us to always verify the RA's replies. We call the API to generate a response from the AI model. We specify which AI model to use for the response. We provide the input question to the model. We close the API call statement. We extract the generated text answer from the response object. We check if the answer exists and contains the word "Paris." If the answer is correct, we print a confirmation message and the answer. If the answer is incorrect or missing, we print an unexpected answer message. We have a blank line for better readability. Running the cell now. Here, the output confirms that the AI correctly responded with Paris, matching our expected answer. This illustrates the lesson's point about verifying responses before using them. By checking the answer content, we ensure the model's reply is accurate and avoid potential mistakes downstream. If answers look strange, handle them or flag for review. Let us build a chatbot that can actually run your math using a function. This lets the model call your real Python code safely. This is a comment describing the mini project, building a chatbot that uses function calling. Here we define a Python function named add that takes 2 arguments, a and b. The add function returns the sum of its 2 inputs. This line is blank, separating the function definition from the next section. We start creating a chat completion request using the client API, storing the response in RESP. We specify the model to use for completion as GPT 4.1. We provide the initial chat messages. Here, the user asks to add 3 and 5. We specify a list of functions the model is allowed to call, starting with an opening bracket. We begin describing the first function in the list, starting an object. We name the function add that the model can call. We provide a short description, add 2 numbers. We start specifying the JSON schema for the function's parameters. We specify the parameters are described as an object. We declare the properties of the object, i.e., the function's input parameters. We specify parameter A is a number type. We specify parameter B is a number type. We specify that both the and b are required parameters. We close the parameters object. We close the function definition object. We close the functions list. We set the function call mode to auto, so the model decides when to call the function. We close the call to client.chat.completions.create. We print the raw response returned by the API call. This line is blank, separating the code block visually. Running the cell now. This output shows the chatbot successfully recognizing the user's request to add 3 and 5 by preparing a function call with the correct arguments A3, B5. Notice that the finish_reason is function_call, indicating the model decided to call the add function rather than respond directly. This confirms the intent of the code to safely handle function calls before executing them, a key step in avoiding errors when using AI function calling. You can build custom calculators, searches, or data lookups with this method. Here is a challenge: you write your own math prompt. The model will use our Python function if possible. This is a comment telling the user to input their own math question. Prompt the user to enter a math question as a string. Call the Chat Completions API to get the model's answer. Specify the model version to use for the completion. Provide the conversation messages, starting with the user's question. Define possible functions that the model can call to solve math. Start the list of available functions for the model to use. Start defining the first function's details. Name the function add, which will add 2 numbers. Describe the function's purpose, to add 2 numbers. Start describing the parameters the function expects. Specify that the parameters object holds the function inputs. Define the first function parameter h as a number. Define the second function parameter b as a number. Specify that both the and b are required parameters. Close the parameters dictionary. Close the first function's dictionary. Close the functions list. Set the function calling behavior to automatic. Close the function call to the Chat Completion API. Print the response received from the model. Running the cell now. This output shows the AI successfully parsed the user's math question and triggered the add function with arguments a = 7 and b = 9. Notice the function_call key contains these argument values, confirming the model recognized the numbers correctly. This highlights how function calls can extract structured data from user input, but remember to wrap this in error handling to catch issues like invalid inputs or missing arguments. Check if the model found the right answer. Try with different numbers or math actions. Here is another challenge. Ask OpenAI for a programming joke and see what you get. This line is a comment describing the challenge to make OpenAI tell a joke. This line starts the creation of a response from the AI client. This line specifies the AI model to be used for generating the response. This line provides the input prompt asking the AI to tell a funny programming joke. This line closes the response creation call. This line prints the text of the first part of the AI's joke output. Running the cell now. This output shows a successful response from the AI model delivering a programming joke, indicating no errors occurred despite using a playful prompt. The key takeaway is that the model returned a clear, user-friendly message, demonstrating that proper input and model parameters lead to expected results. This reinforces the lesson's intent to always check responses before use and prepare for error handling when responses might fail. Try changing the prompt for different kinds of jokes. Recap: what have you learned? How to talk to OpenAI models using Python. The use of chat, short answers, speech, and functions. Best practices for safety, error handling, and experiments. You can now start building AI apps and projects. Running the cell now. Try it yourself and subscribe for more. Play with the code and come up with your own prompts. Share your projects and results with us. Subscribe for more AI lessons and hands-on tutorials. You can do this, AI is for everyone. Running the cell now.